All right, this is part 4 of our video on reducing expressions. We're looking at example C. So we've said so far that in order to reduce, we need to have our expression in factored form because you can only reduce when you have multiplication, not when you're adding things or subtracting things. So I have negative 3 cos squared x plus sine x minus 7 over 27 sine cubed x minus 125. Okay, on the last one, I didn't separate, like take them off to the side to factor. I just did it in place because the exponentials, it just needed a common factor. I don't think we're going to be so lucky here. So I think I'm going to take the first one off to the side and see what we can do with it. And then we'll take the second part off to the side and see what we can do with it. So I have negative 3 cos squared x plus sine x minus 7. And that's what I want to factor. Now I notice it has 1, 2, 3 terms, which makes it a trinomial. I don't see a common factor. And I'm thinking it has something squared, something, and then a number. So I might be able to use decomposition. But the problem is the trig identities or the trig ratios don't match. So one of these is a cos and one of them is a sine. So what I would like to do is maybe use an identity to see if I can find something that would allow me to either write this all as cosine or all as sine. Sorry, yeah, or all as sine. So I don't have my identity sheet with me, so I can't show it to you. But there are 3 identities on your page that contain both sine and cosine. One of them is the one that tan x equals sine x over cos x. One of them is cotan x equals cos x over sine x. And then sine squared plus cos squared equals 1. Because I see that I have cosine squared, I am drawn to the sine squared plus cos squared equals 1. So I want to try to get that cosine squared x by itself so that maybe I could replace this. So I would subtract sine squared from both sides to get that cosine squared x equals 1 minus sine squared x. So I'm going to take out the cosine squared that I have, and in its place, I'm going to put 1 minus sine squared x. I'm just going to refocus that. That didn't help. Okay. So that means this is going to be negative 3 times 1 minus sine squared x plus sine x minus 7. All right, at least now it's all sine. I don't have any cosine, but I do have this bracket. I'm not happy about that. So I'm going to multiply by negative 3. So this is going to give me negative 3. Negative 3 times 1 is negative 3. Negative 3 times negative sine squared x is positive 3 sine squared x. And then plus sine x minus 7. All right, I do notice that the negative 3 and the negative 7 are like terms. So this will be 3 sine squared x plus sine x and then minus 10. I haven't even factored yet. All I've really done is just rewrite my equation so that I'm using the same trig ratio. Because as it was, I wasn't going to be able to factor that. So now I'm going to try to factor. If you feel like you can do it with the signs in it, then use it with a sign in it. And if you're looking at this and thinking, I don't know what to do with that, then I would recommend taking out sine x, not sine squared, but sine x, and then seeing if you can do a little bit of variable replacement. So if I try to use some variable replacement here, I would let a maybe equals sine x. And then I'm going to take out all the sine x's and put in a's. So I'm going to get 3, and then that's going to be a squared, plus, and then that's just a, minus 10. I feel like we've factored this before in another lesson. All right, so I have 3a squared plus a minus 10. I am looking for 2 numbers. So this does not have any common factors. So I'm going to try decomposition. So I'm looking for two numbers that add to 1 and multiply to negative 30. All right, things that multiply to 30 would be 1 and 30. I cannot make a 1 out of that. A 2 and a 15. Nope. 3 and 10. No. 4 does not divide in evenly. 5 and 6. Okay, if it was positive 6 and negative 5, that would add to 1. And a positive times a negative would make negative 30. So I'm going to go for negative 5 and positive 6. So I'm going to take out that middle term and replace it. So I think I'm going to put the 6 with the 3. So I have 3a squared plus 6a minus 5a minus 10. Out of the first pair, I can take out a 3 and an a, and I end up with a plus 2. In my second pair, I can take out a negative 5, and I'm left with a plus 2. So I didn't explain all those steps in there because we've been factoring enough that hopefully you already know how to do this. And then this is a plus 2, 3a minus 5. Okay, but the question didn't really have a's in it. It had signs in it, which means this really is sine x plus 2, and then 3 sine x minus 5. Okay, so that's the numerator. So I'm going to go back to my original expression and replace that with, replace this with that. So this is really sine x plus 2, and then 3 sine x minus 5. In the denominator, we have 27 sine cubed x minus 125. So I'm looking at this, and I see that it has two terms, that they are not perfect squares, but they are cubes. 27 is 3 cubed, 125 is 5 cubed, and then this sign has a power of 3 on it. So this is actually a difference of cubes, which we just learned about. So to do a difference of cubes, I could factor that off to the side, but I feel like I can just go for it. So we would cube root, no, we should write it at the side. I changed my mind. All right, so this is 27 sine cubed x minus 125. If you feel like you would like to use variable replacement here, do it. But I feel like I can handle it on like differences of squares and sums and differences of cubes. So this is the same thing as 3 sine x cubed. You can calculate on your calculator. The cube root of 27 is 3. And then 125 is 5 cubed. You can get that off your power sheet, or you can do the cube root of 125, which tells me it is 5. So I'm just using the second function of my exponent button, right? That's how I'm doing that cube root. Okay, so that means this is going to be the cube root of the first term, so 3 sine x, and then minus the cube root of that second term, which is 5. Then I'm going to take the first term and square it. 3 squared is 9. Sine x squared is sine squared x. I'm going to square that last term. 5 squared is 25. And when you square a number, it is always positive. And then I'm going to multiply the two together. So 3 sine x times 5 is 15 sine x. And then the sign needs to be the opposite of what's here. So if this is a minus, this part here is a plus. It's a bit of a wave going in my writing. Okay, so I'm going to take that and put it in place of my denominator. So I have 3 sine x minus 5. I'm going to have a hard time fitting all this in. So 3 sine x minus 5. times 9 sine squared x plus 15 sine x plus 25. Now that second bracket we said on sums and differences of cubes does not factor unless the original exponent was bigger than 3, like a 6 or a 9 or something like that. All right, so the whole point of this was to reduce. Do I see anything that would reduce? Well, in the numerator and in the denominator, I see a 3 sine x minus 5. So I am going to divide the top and bottom by 3 sine x minus 5. And I'm going to be left with sine x plus 2 divided by 9 sine squared x plus 15 sine x plus 25. And that is my final answer. All right, we have one more part to this video where we will do example D that has logs. I'll see you there in a few minutes.